Hello and welcome to Nerd News at 8. I'm Patrick Hubert.
And I'm Philip Oxford Hemingway.
Giving you everything you need to know before your chemistry test. This hour we'll be looking at something that is all around us, yet we tend to take for granted. Acids and bases.
An acid is any chemical compound that releases a hydrogen ion, that is, a single proton, in a chemical reaction. Acids generally taste sour and have a low pH. That's something we'll talk about later. On the chemical side, acids will corrode metals and produce hydrogen ion gases when they come in contact with them.
A base, on the other hand, is any chemical that releases a hydroxide ion, OH-, in a chemical reaction. Bases usually taste very bitter and are slippery to touch. When in contact with an acid, bases will produce water and a salt. During this reaction, the base will lose its basicity.
And now, over to our sports reporters.
Hello, my name is Aaron E.S.
And I'm Bronze Tail Lowry.
And welcome back to what is looking to be an intense matchup.
It's been an intense game between hydrochloric acid and sodium hydroxide. They're going to the bench for the changeover. They seem very exhausted, so they seem to be taking a sip of water to cool off, but oh no, they just came into contact with water, so they're sure to deionize.
That was water. We're deionizing.
For those that don't know what just happened, acids or bases will deionize when in contact with water. In this instance, the hydrochloric acid lost its hydrogen ion and became Cl-, while the sodium hydroxide lost its hydroxide ion and became Na+.
Now we're on the next court. We have two other players locked in for a fight. Nitric acid is up to serve against water, and whoa! He caught it! Let's see that on replay. Nitric acid donates the hydrogen ion to the water, and he gladly accepts. Now, the nitric acid has become the conjugate base, and the water has become the conjugate acid. Ain't that just nifty?
Well, as you just saw, acids and bases usually ionize in a reaction. The amount that the acid or base ionizes in the reaction determines if it is a strong or weak acid or base.
Yes, and when an acid or base ionizes completely, it is also known as a strong acid.
And strong acids and bases are, well, much stronger than the weaker ones that do not ionize as thoroughly.
And on that topic, over to our weatherman with some strong acids.
Hello, my name is Alejandro Carlos Ignacio Dominguez, bringing you Nerd News Nightly Forecast. As you can see on the map of Georgia behind me, on the west border we kind of have some strong acids brewing around, such as perchloric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, and sulfuric acid. Now those acids are very strong and very harmful to humans, so you might want to stay indoors if you're in this area. Now over on the other side, on the east coast, we have some strong bases kind of whipping around, such as lithium hydroxide, sodium hydroxide, potassium hydroxide, calcium hydroxide, strontium hydroxide, barium hydroxide, aluminum hydroxide, and magnesium hydroxide. That's a mouthful of hydroxides there. That's because hydroxides are a very strong base and are very harmful, so you might want to stay indoors over there as well. Now in North Georgia we have some weak acids, our system brewing. We have some hydrofluoric acid, nitrous acid, sulfurous acid, and phosphoric acid. Now not as strong, but might want to, do a rain check on going outside today. Now in the middle of Georgia we have some weak bases, a system of those: hydrogen sulfate, ammonia, perchlorate, and hydrogen sulfide. I'm Acid, and that is your Nerd News Nightly Forecast. Thank you for that extremely useless forecast, Alejandro. Anyway, now on to our guest speaker of the night, Charles Crodhammer. Great to have you on the show tonight, Charles. Now, the question that we've all been asking: what are these things that we call pH and POH?
Funny you should ask, seeing as you guys' initials are pH and POH. Well, pH is a scale from 0 to 14 to determine how acidic or basidic a solution is. A solution's pH is a negative logarithm of its hydrogen ion concentration, which tells us how acidic reaction has occurred. The POH scale is the inverse of the pH and measures how much hydroxide is in a solution. 0 to 7 on the pH or 7 to 14 on the POH is acidic, and vice versa for bases. It's been my pleasure receiving all this information. One and action.
Well, thank you very much, Mr. Crodhammer. Really wish I had known that before I just had an identity crisis. I'm gonna call my mother real quick. Hey, Mom?
Yeah, while he does that, anyway, Mr. Crodhammer, is there, any other way to find out how acidic or basidic a solution is? Well, Phil, there is something called litmus paper that can determine if a solution is acidic or basidic. All you have to do is stick this slip of paper into a solution, and if it's red, it's acidic, and if it's blue, the solution is basidic.
Well, thank you for that, I guess, Charles Crothammer. Now on to our consumer reporter, Tom Byer. Thank you very much. Today we'll be looking at some household items that contain acids and bases you maybe didn't know. First of all, we have vinegar, which contains an acid, also jelly. Another one of those is batteries. Yet another is oranges. Also, we have soda, which contain acids, and ketchup. Those are a lot of household items that you didn't know contained a lot of acids. Now, there are also just as many that also contain bases that you also probably didn't know about. First of all, we have milk. We also have shampoo, which is a base, but you didn't know. Another one is bleach, which might be obvious to a lot of you. And there's one that most people don't know, including myself. Toothpaste, but also eggs. But believe it or not, eggs are bases. Now for the pHs of some common fluids you might encounter in everyday life. Water, of course, is perfectly neutral and has a pH of 7. But blood is slightly basic with a pH of 7.4. Milk has a pH of 6.6, grape juice is 3.3, saliva is 7.2, honey is 3.9, Drano is 11, Pepto-Bismol is 8, Windex is 10, hand sanitizer is 5.5, and nail polish remover is 6.
Thank you very much, Tom. And now to a special guest all the way from Aikens Laboratories, Benjamin Buffer. Thank you very much for having me on here.
So Benjamin, what exactly is a buffer?
A buffer is an aqueous compound that neutralizes an acidic or basidic solution. That is, it keeps the pH from changing. A buffer is pretty simple. It's just a weak acid combined with its conjugate base, or a weak base combined with its conjugate acid. Buffer solutions are very useful in chemistry because they are solutions that have a constant pH. Thank you very much, Bethany.
And now on to our on-field weather reporter, Robert, for the newest development.
Hello, my name is Robert Andrew Isaiah Newman, and welcome to Nerd Nightly News. We appear to be caught in an acid rain shower. Acid rain occurs when water molecules and clouds combine with harmful atmospheric pollution, such as sulfur and nitrogen oxides. This precipitation is not water, but an acidic solution that is sure to cause damage to plant and marine life. Back to you.
Thank you very much, Robert.
And from us to you at Nerd Action News at 8.
Good night, Cherokee.